Your GitHub OAuth integration is working locally, but now you need to actually use it to build secure, user-specific tools. We'll implement a production-ready FastMCP tool that lists a user's private GitHub repositories, showing exactly how to access authenticated GitHub data through your MCP server. The pattern handles token management automatically, so you can focus on the tool logic. From FastMCP, import FastMCP. Hash authentication is automatically configured from environment. MCP equals FastMCP. Name equals GitHub secured app. At MCP, tool. Async def list repos, list SDR. A list the authenticated user's repositories. Hash your tool implementation here. Pass. This demonstrates the OAuth proxy pattern combined with declarative tool registration. The code shows how to secure a FastMCP server using GitHub OAuth without manual token handling, while exposing Python functions as callable tools through simple decorators. The distinctive aspect is how it bridges traditional OAuth flows with modern RPC frameworks, letting you focus on business logic rather than authentication plumbing. The pattern works by externalizing authentication to a dedicated provider that handles GitHub's OAuth quirks, while the decorator system maintains clean separation between security concerns and tool implementation. FastMCP's GitHub provider manages the entire OAuth flow token exchange, validation, and user context propagation, while your tools remain pure functions with typed interfaces. This separation means authentication becomes an infrastructure concern rather than application logic. This approach matters because it solves the dual problems of secure API exposure and developer ergonomics. You get production-grade OAuth security without writing authentication code, while maintaining the simplicity of Python function definitions. It's particularly valuable for internal tools, AI integrations, or microservices where you need both strong authentication and rapid iteration, without the overhead of manual API development. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for defining AI callable tools. It handles authentication, tool registration, and schema generation from Python type hints and docstrings. Hash authentication is automatically configured from environment. MCP equals FastMCP. Name equals GitHub secured app. This initializes the FastMCP client with environment-based authentication, eliminating hard-coded credentials. The name parameter identifies this toolset in logs and error reports, enabling better observability. This is the standard entry point pattern for all FastMCP applications. At MCP, tool. Async def list repos, list SDR. A list the authenticated user's repositories. This decorator exposes list repos as an AI callable tool through FastMCP. The function signature and docstring automatically generate the tool's schema, including parameter types and descriptions. The async keyword enables non-blocking execution, critical for tools that may perform I/O operations like API calls. This pattern ensures your Python functions integrate seamlessly with AI workflows while maintaining clean, type-hinted interfaces. Hash your tool implementation here. Pass. This placeholder marks where you implement the actual tool logic. The pass statement prevents syntax errors while keeping the function structure intact, giving you a template to fill in with the real repository listing code. FastMCP GitHub integration. The MCP tool decorator transforms Python functions into AI callable endpoints, while GitHub provider handles authentication transparently through environment variables. Environment variables must be set before instantiating FastMCP, or the server will fail silently during startup. This pattern lets you focus on tool logic, while FastMCP manages security and schema generation.
The tool that never asks for credentials becomes the most secure gatekeeper.